Hello, my name is Nigel, and today I'll be going through the state pattern. Um, so what is the state pattern? The state pattern, it is a behavioral design pattern which alters its behavior when the internal state changes. So we can look at an example of the state pattern, as seen. A good example of this is basically the three states given in a traffic light: red light, green light, and yellow light. And when its internal state changes, such as a car is waiting to move or a pedestrian waiting to cross the road, then it will change its state. So we're given the constraints: red light lasts 6 ticks, green light 4, and yellow light 1. And then we're also given a bunch of information about how the durations change based on the number of cars and pedestrians on the road. Okay, so going on to the starter code that we're given, obviously just very basic, hasn't been implemented with a state pattern yet. We can see the constraints demonstrated here where red light goes to green, green light goes to yellow, and then yellow to red. And then this count is basically when it starts off as a red light, the count equals 6, and every time change is called, if the count is not 0, then we decrement. And then otherwise, it changes the state through here. So first, we should create the state folder. Just keep all the stuff in one place to make it neat. And then we'll create the traffic light state. So this would be the superclass of all of the different states that we can have. Can either be an abstract class or interface. In this case, we're using interface because we do not need to have any fields inside the traffic light state, just methods that need to be implemented. So obviously taking all the 3 different methods that we need to implement into the state pattern, very similar to the strategy pattern. We just implement the stuff and bring it out of the traffic light class into a design pattern. Cool, so we'll just quickly bring these up. Okay, and then just to make it simple, we'll create all 3 files now. Green light.java, yellow light, and red light.java. Okay, we'll start off with the green light. So basically, as I said before, traffic light state, it's a superclass of the different states that we have: green light, yellow light, and red light. So this just means that we have to write it implements traffic light state. Cool, and then we will just command control dot, and then we can just add unimplemented ones. Cool, so I'll just write some stub code just to make it easier for us to look at. Basically, we want to use the logic used here and then just put it onto the green light class. So we can just copy this over. The change, actually I'll just copy over the whole thing. I'll copy over the whole thing and then delete the useless stuff, obviously. So red light, no. And then we just want to keep this logic here, and we can get rid of that as well. Okay, so as you can see, the green light, we don't actually need to use the traffic demand function, so we can actually get rid of it, whereas the red light and yellow light will be using the functionality there. So we can actually just get rid of this completely. And basically it'll just be if count is greater than 0, decrement count, else we will change to a yellow light. And then yellow light runs for 1 tick. So as you can see here, if state equals yellow light, the count equals 1, so it'll set the count to 1 tick. And then we can just copy over the other functionalities here. So time remaining just returns count. and report state, green light, return green light. Cool. This one we don't have to change because it's perfect. Except obviously these, you'll see the count is highlighted in red because we don't actually have access to the count field from the traffic light. So one thing that I will be doing is actually adding the traffic light field to each of the different states so it has access to the counts. So I'll just be writing this, and then we have to create a constructor for green light. So green light, and it'll take the input of a traffic light. Traffic light. This dot traffic light. Cool. And basically, when a green light is created, the count is set to 4. So we would actually need to create a method here, which is just a void function where it can set count. And then just make it an int. And we'll just set the count equal to the new count. Cool. So in here, we will just have to do traffic light dot set count equal to green light 4. Cool. So we'll just set that to 4. Variable traffic light must be private and have access to methods. Sorry, I forgot to add that in. So add that. Okay, so now that we have access to the traffic light that we are actually using the state pattern on, we can change our change method. So if count is greater than 0, so we'll just need to go public int just count equals, and then just return count. So just go count traffic light dot count equals, and then so basically if the count is greater than 0, then we need a decrement. So we can just create public void decrement count, and it'll just make count equal to count minus 1. Cool. So traffic light dot decrement count. So basically if the count is greater than 0, then we will decrement count. Otherwise, set the state equal to yellow light and count equals to 1. So what we'll do here is just traffic light state equals yellow light and count equals to 1. Okay, so we would actually do this inside the yellow light function, and it'll just call the traffic light change state inside here. So we'll just leave that there for now. Return count traffic light dot count equals, and then we can go over to here and just very similar stuff, just copy it over, and instead we'll just change this to a yellow light, and it will have a count of 1, so we need to change that to 1, and void numcars must override or implement. That's fine. Same thing here, but instead we just need to get the logic from here. So state equals to red light and count is equal to that. Cool. Red light and count equals to that. Yep. And we will bring this over to here now. Yeah. Same thing, time remaining. Sorry, forgot to do implements traffic light state. Yes, that should remove all the errors that we had. And this must be yellow light. Oops. Yellow light. And then we will bring this also over to the red light. It's just very fast once you get one of them done. Red light, if they all have very similar functionality, obviously different if they don't. So we'll just grab the red light logic, copy it over. Bang. Time remaining, and this one also implements the superclass. Traffic light state. Okay, so now we can just get rid of all of this very ugly code and change it into the state pattern. So first we will have the state. So the state is basically just telling us which part we are on. So red light, yellow light, or green light. So if the string equals red light, green light, or yellow light, we can change this into a switch statement. So we'll keep the this ID equals ID, because we need to know the ID of the traffic light, and this can all be changed into a switch statement. So we'll go switch state and just bring it out. So where our first case would be red light. We'll just go start with green light actually. Green light. Okay, so when our thing is created as a green light, at the start we basically just said state equals green light. So this equals green light. But now instead we can change this into traffic light state. And we can just have it called traffic light state, for example. And basically instead of having a string that holds which state we are on, we're instead having the actual object traffic light state, which would hold which one we are on. So then we would just, if case equals green light, we'll just create this dot state, traffic light state, is equal to a new green light, where we will use the constructor used here, and it'll have itself as the input. And then we'll just break. Okay, next case, just copy this over, make it a bit faster. Yellow light. New yellow light. And then red light. Red. Cool. Red light. How come it's red? Cannot be resolved to a type. This is fine. This. Import red light. Okay, cool. So switch state without a default clause. Oh, forgot the default. So default and just break. Cool. Actually, we'll set the default traffic light state to equal new red light, so there's no issues in the program in case it doesn't actually give us one of these states. It, for example, gives us like purple light or something. We'll just set it to red light, and then it can continue from there. Here, change. Do not need all this anymore. We can get rid of that, and then just simply we can just call the traffic light state dot change. Right. So once we use this, very similar to a strategy pattern where basically we just call the pattern to do the logic for us instead of having it all inside the object here. Same thing here. Although it's one line, we also do bring it out in case, because of the open close principle, it allows us to add more to the pattern. So for example, in case time remaining had some new functionality, such as like if a purple light time remaining was plus 100 versus the original, just count, then we would have to implement it here as a, oh, if the state equals purple, then add 100 to count and return it. Otherwise, we can just return this. Report state, same thing here. You can just get rid of it. State. Return traffic light state dot report state. Cool. Alright, so we still have this as an error. So what I said was that we would add it into the original traffic light object, the functionality to change states. So first we'll just create a method which is just public change state, so void change state, and then it'll be a traffic light state new state, this dot traffic light state is equal to new state. Cool. And then now we can use them here to just change the state in the traffic light to the new state. So traffic light dot change state. Traffic light dot change state into a yellow. Yellow light, traffic light. Nice. And then this would be the same for all of them. So we'll just copy this over. Red light. Yellow light changes to a red light, so new red light. And same for red light changes to a green light. Green light. Okay, so now we need to access the count. So we already have a set count method we can use, so we'll just input this. So set count equals to 1. So traffic light set count and 1. So just using the exact same logic that was already in the starter code given to us, we will just change this. Dot set count. Yep. And the exact same thing here. Just copy this over. Cool. And then this will basically have the exact same functionality as the starter code given to us here, where we just basically replaced all the logic and just for the creation of it, we're allowed to have a switch statement because this is the only way that we can ever create a state pattern. But then from then on, each of the methods used will just call the state pattern. Right. So that basically just wraps up what a state pattern is. It just allows us to extract all the logic from a class and then just put it into a pattern where we can, and just basically just allows us to edit it very easily. So if we, for example, in the starter code we wanted to edit, change the green light from 4 ticks to 5, we would have to go into the code and change it here. Or for example, we wanted to change it to you know, some different logic, we would have to go into the main function and change it all. Whereas just here, we can just go into the object here and just change it right there.